This is the new CaddX Avatar GT VTX. Now, this is their new high-power VTX that CaddX say is capable of up to 2,000 milliwatts of power. Now, this is sort of a review, but it isn't. You're not going to see me flying this VTX in this video because it is not legal for me to use this VTX on those power outputs. This is going to be a technical deep dive into this VTX. I have been using it legally, I have been testing it, and there's an awful lot that you do need to know about this, and that is what I'm going to cover today. Now, just to be clear before we get into it any further, CaddX did send me this VTX over to take a look at for free. They haven't paid me to make this video, they've not seen this video before it's been published, and as always, my thoughts are entirely my own. Okay, so the GT kit is CaddX's new up to 2 watt of RF output VTX. Now, I'll talk about that power subject a bit more later on. Now, this is a new VTX unit. It does have a built-in DVR, but there are some quirks around that you do need to be aware of. This kit here does come with the Pro camera as well. That isn't the same as the Moonlight camera. The Moonlight camera is capable of up to 4K. This is the Pro camera. That is 1080p, but it does support gyroflow, so you do get gyroflow recording on this as well. Now, this module, as you can see here, is a lot bigger than the other VTXs that we've had from CaddX before, although it is similar in the sense of it's the same overall size and shape, it's just taller with regards to its height. Everything else, though, with regards to its footprint is very similar. Now, the first thing you'll notice on this VTX is there is a big fan installed on the top, and that is to try and keep it cool because it does have up to 2 watt of RF output. If we look around it, the first thing you'll see here is we have our usual MIPI connection input for our camera, exactly the same as on all of the others. We then, on this side here, have our RF outputs to our antennas, again, pre-installed from the factory. On this side, you can see there is an SD card for the DVR and our bind button, little LED. And then on this side here, we have our I/O. So we have our main power input connector here. There is a mirrored UART connector here. So you can see on this connector, you've got V-in, ground, RX2 and TX2, and you've got RX2 and TX2 here again, although there's a power output here which is 5 volt. That is actually the power output to supply the fan. You can see that it is actually covered over. It is not a 5 volt input for the VTX. Do not use it for that. There's no hardwire pads on this for connecting the power. You have to use it via that connector there. With regards to that power input, it does support 11 to 25.2 volts, basically 3 to 6S, the usual input range that we have on the Avatar HD VTXs. Now, with regards to the DVR on this, as I mentioned, there is a bit of a quirk that you need to be aware of. As I've said, it comes with the Pro camera, but you can use this with the likes of the Moonlight camera that supports up to 4K. However, there is no 4K recording on board the internal DVR. If you do want 4K recording on the GT unit, you can install CaddX's separate DVR module that goes between the camera and the VTX. That is fully compatible with this unit, and that would give you your 4K DVR on that unit, but you cannot record on 4K on the built-in DVR. There's also a bit of a quirk on the SD card as well. It's not a latch-in SD card slot. Now, I have no idea why CaddX have done this. In the packet for this, they include these little pieces that allow you to stick these tabs onto your SD cards. So what we're going to do is just demonstrate that on one of mine now. Let me just get them out. They do give you some spares for this. You can see them there. Then when you remove it, you'll notice that one part of it is sticky, and it allows you to attach it to your SD card like this. So you can see that. And then when you put your SD card in, I'm not sure which way around it goes in like that, it seems. Let's give it a push. There we go. The SD card has gone inside the VTX. And this is how you remove the SD card when you need to get it out. You need to give it a pull and it comes out. Warning, if you were to install your SD card without this tab, and I'm just going to use this other one to push it in, just to show you how far in that goes, you are going to find that almost impossible to get out without the tab. So do not try to install that card unless you have done this. This is a very weird quirk, if I'm honest. I cannot get my head around why they've chosen to do this and not use a latching card. Now, as you can see, this VTX does have 2 antennas for transmitting, but it actually has a little bit of a secret, and that is there's 4 antennas in this VTX. There are your usual 2 here for your main transmission output. However, when this VTX is in low power mode, it doesn't actually use these antennas. There are 2 internal little chip antennas located on the PCB internally in this VTX that are used when the VTX is in low power mode. It only uses the main antennas when you arm the VTX and put it into full power mode. Now, this is a bit different to what we've seen from CaddX in the past, and as a result of it, it does mean you won't get the same range on this VTX in low power mode as you will on the others. And in fact, my understanding is the range is actually greatly reduced in low power mode on this. You actually need to be right on top of it to be able to pick it up on your goggles. It is so low that you will only get a few meters of range max from the VTX, and it could even be less if it's buried in a frame. Here, you will see me get up and actually walk off. I don't get 2 meters away from the VTX on the table before the signal drops. We will talk about this a lot more later on in the video, but I did just want to demonstrate the actual behavior here so you can see it for yourself. Now, just looking at the actual size of this VTX, if we put it in my calipers, it is 34 wide there. 34 wide there, just under. We'll class that as 34. And then with regards to height, and I'm going to measure the height to the posts that stick out at the bottom, which is there. You're talking 23.5, so I'd class it as 24. Now, with regards to the weight, with the Pro camera installed, the antennas, the only thing that's missing is the power cable. We're talking about 47 grams. Next, we're going to jump into the more technical stuff on this VTX. Now, we're going to take a look at power consumption, look at it under the thermal camera. We're going to then take a look at it from an RF perspective on the spectrum analyzer, because there's some interesting stuff going on with this one. And then we're going to tear it down. Looking at this chart, you can see I've tested the consumption in 3 different modes. We have standby mode, we have 25 milliwatts, and then maximum output of what they say is 2000 milliwatts. Now, whilst you can see the milliamp rating here, this was tested at 17.35 volts. This is going to vary depending on your voltage input, and the real important information here is the wattage, and this VTX on maximum power draws just over 15 watts. That is in line with the likes of the DJI O3 Air unit and others that we've seen, so you're going to want to put this on a BEC of about 10 volts, 1.5 amps. Ideally, you want a 2 amp BEC for this one, but it should be fine on a 10 volt 1.5. What you're going to have to be careful though is if you drop below 10 volts, some of the 9 volt BECs are going to need to be 2 amp rather than the 1.5. What there isn't is any crazy power draw here compared to any of the others. It is very much on par with what we've seen in the past. Taking a look at it under the thermal camera, here you can see as we power it up, the heat start to increase in this middle area on the bottom of the VTX. It's worth noting that the way this VTX is designed is that the bottom half has the main board with the avatar chipset on, the main ASIC, and the top board, as you'll see later on in the teardown, has the power amplifiers. The fan is directly cooling the power amplifiers, but it isn't cooling the main board that is located at the bottom of the VTX. And as a result of this, you're going to have one board in the unit getting cooled as a result of the fan on the top, and the bottom board passively cooling as a result of it being mounted to the bottom section. Now, obviously, there will be the movement of heat around the external of the unit because it is metal, but the top and the bottom sections are actually 2 separate parts. They do meet, so there is going to be this thermal barrier between them. You can actually see it there when you look at the side of the VTX. You can see the bottom panel being hot, then the center section, which is a separate machine part, not quite having as much heat in it, and then the top section being cooled by the fan. You are definitely still going to need airflow on this VTX, even around the bottom of it in use, and whilst the fan will help to keep it cool, it cannot completely keep it under control. In my tests on the bench in a room of about 20 degrees C, it will still overheat. The fan is going to help, but it certainly isn't going to remove the need for airflow, especially over the bottom section of the unit. Next, we're going to take a look at the RF testing. Now, there is some interesting things going on here with this VTX. It actually works very differently to the previous ones, but there's also some things here that aren't quite right as well, as you'll see as we proceed through the next bit of the video. Okay, now the first thing to explain to you here is that we have the DJI digital FPV system on the left set at 1200 milliwatts and the Avatar GT VTX on the right set at 2000 milliwatts or 2 watts. This setup is done in such a way that it should be identical behavior in how they perform. There should be very little outside effect as a result of this testing on the carrier levels that you're seeing here, and the only differences that you should see are as a result of the power differences in the systems. Taking a look at the carriers, you can see that the Avatar one on the right-hand side is showing more amplitude. It is a stronger carrier than the one on the left, which is DJI. The two interesting things to look at is our markers. So our number 2 marker, which is the average there in yellow on the DJI system, is lower than the average marker on the right on the Avatar. And that is also the same for the other marker, which is in red at the top, the quasi peak. You can see that on the DJI is lower than it is on the Avatar HD. Overall, the amplitude of the carrier on the Avatar GT VTX at full RF power is higher than it is on the DJI digital FPV system on full power. Now, I am going to be clear again in saying that I don't believe there is any way to reasonably show the actual RF power levels of a digital FPV system on the bench. There is no testing that I am comfortable in doing and providing you numbers that are matter-of-fact accurate. So as a result of that, I will not do it. What I will do, though, is give you my opinion based on my spectrum analysis, show you information like this, and then give you what I feel is what I am seeing. And what I am seeing here is that the Avatar GT VTX is absolutely producing more RF output than the DJI on 1200 milliwatts. I'm not going to tell you that it is out and out 2 watts of RF power, but it is definitely more. I feel it is reflective of the kind of jump that we saw from the likes of DJI at 700 milliwatts all the way up to 1200. And whilst that doesn't necessarily mean it's absolutely 2000 milliwatts, I am comfortable that this VTX is putting out something in the region of that, and it is certainly more power than we've seen on any of the other VTXs. Now, the next thing I want to talk about is the low power mode, because as I mentioned earlier, it actually works a bit differently on this VTX compared to the others in the sense of, instead of it using the normal antennas here, it uses some internal antennas, which we'll take a look at later on. It's also, though, different in the fact of it isn't outputting the same RF power as the other VTXs in low power mode either. Now, just to demonstrate this, we have the antenna input here from my spectrum analyzer. This is a dual band 2.4 5.8 gigs antenna, and here we've got this VTX, and we've literally got an inch of gap from these antennas to the input of the spectrum analyzer, and we've got probably 4 inches, 5 inches from the VTX itself. Now, with regards to low power mode, there is some very interesting behavior on this VTX. Currently, it is on low power mode, and on the screen you can see here the 10 megahertz carrier from the goggles. So if I bring the goggles in closer to the analyzer, you can see that signal appear, and then if I move it further away, you can see the signal disappear, or at least reduce. You also have the VTX transmitting right now. However, I have my analyzer set as sensitive as it can be, and it is basically undetectable. The way the old VTXs worked is in low power mode, they would actually output 25 milliwatts, the lowest power setting available in the goggles. Then when you armed or turned off low power mode, it would jump to whatever the preset setting was. So for instance, if it was set to 25 milliwatts, nothing would change. Or if you were set to 700 milliwatts, it would jump up to that. This, though, is not outputting anywhere near 25 milliwatts. It is the lowest signal that I have ever seen out of anything. In fact, it is so low, it's not even visible on my spectrum analyzer. I can get it to show if I really boost the gains, but what I think they're doing is actually bypassing the amplifiers and routing the signal to the internal antennas directly, either out of the RF multiplexer or out of some preamplification, but it is an extremely low level, and that is why you're seeing a reduction in the performance in low power mode. If we arm this VTX, you will then see the video carrier kick in. I've currently got it set to 25 milliwatts, and I'm going to turn off low power mode, and boom, there you can see the video carrier has appeared. You may though have also noticed a load of noise appear here as well. There was a load of carriers that appeared here, and there's this big lump that has appeared here as well. I have noticed that in the 25 milliwatt, the 200 milliwatt modes, this VTX is quite noisy to say the least when it arms. What you will have also noticed though is that some of the carriers came up really strong and then faded away. It is a really strange behavior that I haven't seen on another VTX. It tends to be less noticeable on the higher power settings. It is something that I want to highlight that people should be aware of, because it could have an effect on people flying around you, especially if you are using this on the lower power levels. Again, if I just go into the settings and we turn off low power mode a minute, you will see all of those carriers fade away. If I just adjust this so we move down the band a little bit, carrier is actually here. When I do this again, you will now have a better view of that noise that starts. There you can see it appearing and then sort of fading away over a few seconds. You do also have this lump here, which is on 5820, but it is worth taking into account. I am very close to the VTX at this point. This may not be something that has an effect on people flying around you in the real world, but it is worth knowing about. Now, here is some of the additional testing I've done around this noise on ARM. If you see here, when we kick it in, you can see a huge amount of noise appears. I'm really not sure what is going on here, because I've done testing and there are times where it does it all of the time. There are times where it doesn't do it at all. It does seem to predominantly do it in the lower power mode settings, but it will also do it in the higher power modes as well. But what is really weird is if it's doing it and it stays like it is here, if you then just switch the power output down a level or up a level, it will just slowly fade away after a few seconds, and then it is gone for the period that it is armed. This is unlike anything that I have seen, as I've mentioned before. It's worth noting that this is coming from the VTX, not from the goggles. It is something that could be very problematic. It also is something that may not affect people at all, but you are certainly not going to want to be flying this VTX around people at low range. That is for sure. This is a long range VTX. And there is something very weird going on that we'll talk about a bit more when we do the teardown. One other comment I just want to add on to this, because I forgot to mention it then, is I have not torn this VTX down at this point. This VTX has been fully tested before I broke any of the covers. The teardown is coming next, so this is how it has come to me from the factory. The last thing I just want to quickly show you is the difference in power levels between the power options. So at the moment we are in 25 milliwatts. I'm going to show you going to 200. You can see that there was a step increase there in the carrier. So again, if I go down to 25, you'll see it drop. Up to 200. Up to 350, there was a mild increase. Up to 500, there's a very small increase. What you will notice is as we move up the power levels, there's a bit more of a delay in how long it takes to actually show. It's almost like the amps are ramping up. If we then move up to 700 milliwatts, there is a very slight increase between the 5 and 700, although it might be like the other VTXs and remains the same. It's hard to actually see a change here on the analyzer. It is a subtle change from 500 to 700. It's just not really enough that the analyzer can see it. If we then go up to 1,000, it increased a little bit again, and you can see it slowly increasing over time. Go up to 1,200. You can then see it has increased again there. And then if I now go to 2,000, hit the button and wait, you will start to see that signal increase. You can see the lump around the carrier increase on either side. This is normal because we are so close to the VTX here. You're going to have the lobes off the side of the carrier with this much RF power. What I can do is actually reduce the sensitivity of the analyzer there. You can see it is much smaller. And if I now just drop it down to say 1,200, you will see the signal start to slowly drop down. And if I drop it down to 25, you will see a dramatic drop in power down there. Now, one thing I will just say is, whilst you may try to make some thoughts and opinions on the difference in RF power levels based on the dB scale on the side, this is not measuring RF power. This is measuring actual received signal via an antenna. I can use this analyzer to measure actual RF power, but as I have said already, I am not comfortable publishing numbers that I can't back up. In fact, there are many ways of measuring RF power, and in the end, the way these things are certified, there is no simple way to do it outside of a proper certification lab with a certified spectrum analyzer with a golden sample in a specific setup. Next, we're going to do the teardown. And just to be clear again, that all of the teardown was done after all of the initial testing. There's nothing that I've done in the teardown that will have any impact in the testing that's been done up until this point. Now, the first thing we're going to do is undo the bolts on this side here. I assume these are going into the fan and hold them in place. I'm just going to pop these screws to the side. This will also release the plate for the MIPI connector for the camera as well. So if you did want to replace the camera, you can just remove these two, this one and this one. If you wanted to put on the Moonlight camera, for instance, which does do the 4K, you would then simply lift the plate. We would then need to very carefully release our MIPI connector. That one is quite tight. Let me just grab a pair of tweezers. There we go. That one's released. So again, we're going to pop that safe. And then we're going to undo the last screw this side, which should then release our plate as well for our antennas. So again, nice and easy to access. Pop these off very carefully. And then our fan has come loose. Our metal cover for the fan has come off. And then our fan has come loose as well. You can see the maker model of the fan there. So it is a 5-volt fan. 0.15 amp. And the wiring for that goes through under there. So there's no unplugging this at this point. It is just wait and see what happens when we're moving further. Now we have a choice. We can go in either side. We can go in the bottom or we can go in the top. So I'm going to choose the top for this one. And it is Phillips screws that hold it together around the sides. The disassembly on this isn't particularly difficult or different, I should say, compared to, say, the Moonlight VTX. Although I haven't seen inside this yet, I'm hoping there isn't something like that silly MIPI cable that we had inside the Moonlight that did make things very, very challenging. We're then going to carefully release that. There we go. We have a nice long MIPI cable that goes from the bottom board to the top board. That's much better done than in the past. There is some glue that holds that MIPI cable in place on that side there. So what we're going to want to do is carefully release that and release this MIPI connection. That way we'll be able to separate the boards I'm going to just try giving him a little bit of a tug. Nope, that's held down quite well. What you usually have on these connections is like a little lip on the side, but it isn't that easy to see in this. I'm going to leave it that side a minute, and what I think I'll do is let's see if we can release it on this side. Now I'm guessing there's thermal compound that is holding the top to the bottom. There we go. That was not particularly unexpected. Some of that has come across over to that connector. I would definitely rather remove it that side, because that way I'm keeping away from this thermal compound on this side here. There we go. A bit more of a bit more pressure. Release that. So there we have our video board, is what I'm going to call that, the video processing board. This isn't like any of the other boards that I've seen. It's not like the Moonlight that has a VTX in there, a standard version 2 VTX that they've modified. This looks to be a custom board. So to access this side, we're going to want to undo the screws here. Fairly straightforward to take apart. What I am going to say is this probably is not a board to consider running naked, that is for sure. I know people like to do naked modifications, but on a VTX of this power output, there we go. So we've just separated that off like that. There you can see that SD card slot. I still can't quite get my head around why the choice of non-latching. To me, that just seems like madness. You've got the SD card, you've got the SRAM, you've got a voltage regulator over here, and our MIPI, and really, that's all there is on this side of the board. If we then carefully give this a pry, because I am guessing it is purely thermal compound that is holding this together. Oh yes, and lots of it at that. There we go. Actually, so this does look a lot like the V2 VTX on this side. It's almost like one side of the V2 VTX. So we've got our main chipset there. We've got our RF transceiver there from the look of it. We've got our, I suspect, dialogue voltage regulator. It looks really similar. It does. We're going to have to clean all this up to have a look, but there's nothing particularly surprising here, that's for sure. The only real difference actually is that they've put an SD card slot on this. So that's the real big difference on this board, is that they've really, what they've done is offloaded the RF to this board and put the video recording on this board. Now, I said that was the RF transceiver. Yeah, I'm not seeing the transceiver there. So I suspect that there is the IE2000 as they label it. And then this purely has the power amplifiers in, which we'll take a look at in a second. Now, on this side of the board, it all looks to be voltage regulation. So we have voltage regulator, voltage regulator, voltage regulator, 3 coils, bind button, LED. Yeah, very little on this side of the board at all. And then there's a metal can on this side. There's a big diode here for protection. There you can see the little antennas, and we will get this under the microscope so you can have a look in a minute. And then we have our shielding can, which is our RF shielding. Now we're going to see if we can... This doesn't look like it's soldered on, so I'm hoping this will pop free. Yes, it will. Get ready with the trumpets. Here's the moment of truth. Some little thermal compound on the bottom of that. And there we have our RF power amplifiers, 4 of them. Very interesting. I have a belief already on how they will actually be running the PAs on this, and we'll talk about that in a minute in a bit more detail under the microscope. It looks like that is the case. We then have our internal antennas. Yeah, nothing shocking, but I think what we need to do is get it all cleared up. We'll get it under the microscope, and then I'll give you a better idea of what is actually going on here. So, taking a look at the RF board under the microscope first of all. Now, here we've got our 2 UFLs. Quite interesting that my one on this side has a load of crud on it. Weird. I think that's some of that in powder form that hasn't been removed. Okay, I'll need to remove that before I put it back together. Anyway, we've got our 2 UFLs. Either side of these, you will notice these little components called C1. These are those internal PCB antennas that I mentioned earlier for low power mode. There's 1 on either side, 1 in a horizontal and 1 in a vertical polarization. So you've got 1 here and 1 here. You notice the tracks for these going up and heading off inside, tracks for this going up there, tracks for this going up there, and then tracks for this one heading off in there. So it uses the main UFLs for the main RF output and these little antennas here for low power mode, but they're not linked here. They go further up, and we'll talk about that in a minute. Now, the way this board is laid out is actually incredibly interesting. It's quite different to what CaddX have done in the past, but in some ways it's very similar to what HD0 have done on their Freestyle VTX. And to explain that, we will start at the bottom at the UFL. So our antenna tract from the main RF output comes out of here up into this little IC here. This IC is labeled J3275N. I believe this is an RF switch, and I'll explain why that is the case in a minute. The signal then comes out of that RF switch up into this little component here, which is a splitter combiner. And you can see then the signal splits either way into these big Skyworks ICs here, which are the main power amplifiers. Now, these are the Skyworks 85408-11s. They are 2 power amplifiers designed for 5 gigs, capable of up to 26 dBm of gain each. If we then just follow the circuit back up, you can see it comes out the top, again in that same Y arrangement, back into this splitter combiner. Then it comes out of here, up into this component here, which is a 4521L, and I believe this is a preamplifier. Now, this circuit is a little bit different to what we've seen in the past. They're using dual amplifiers on each side, so you've got 2 on the left and then 2 on the right. The circuits are mirrored, so you've got on both sides what looks to be a preamplifier. Both sides, the signals come down into this splitter combiner, split into the PAs, out of the PAs, down into an IC. There's another one of those switches under this little metal shield here. It's hard to show you, but it is down around there. And then it heads off to the UFL. Now, this amplifier setup is what I believe is called a push and pull setup. It basically doubles the dBm output of the input with regards to its amplification. So if each of these is capable of 26 dBm, it basically doubles the gain. So whatever gain you were getting, and I don't mean it will double 26 dB, it is an incredibly complicated thing to explain, but the very basics are using a push-pull setup. You basically equally split the RF signal between the 2 amplifiers, recombine it at the end, and that gives you the increased RF output, and that is how they are achieving that up to 2 watts of power. Now, the reason I believe this is a switch is because this setup is a bit different as well, in the sense of the power amplifiers you find in DJI and the power amplifiers you find on the normal VTXs are actually a bit of a 3-in-1. They are a PA, they are a switcher, and they are a preamplifier for the received signal. This amplifier, though, is just a PA. There is no switcher on board. There is no preamp on board. Now, the reason you need a switcher and a preamp is this is an OFDM signal, which is constantly going from a state of transmitting to receiving. So it's transmitting, receiving constantly. And when it needs to go into the receiving phase, it needs to bypass the PA. It needs to basically route the signal around the power amplifier so it can go back into the circuit. Now, the other PAs that you get on the normal VTX have that feature built in, but these don't. So as a result of that, what it looks like is CaddX have put a switcher down here. So when we're in transmit, the switcher basically feeds the signal through from the PAs, from the combiner and out to the UFL. However, when that signal then needs to go into receive mode, because these don't have a bypass, what it then basically does is bypass the signal out to the side here. There's another one of these under there for this UFL down here, and it sends the signal up here. You can see it coming up here, the tracks going up and disappearing out there. And what I basically believe is when it goes into receive, it bypasses the PAs and then sends the signal out the back end to the transceiver so it can do with the receive. Basically, as a result of using this choice of preamplifier that doesn't have a built-in bypass, CaddX have had to add additional circuitry that allows the bypass separately. Now, with regards to this receive signal, there is what looks to be a little preamplifier down here as well. You've got a Skyworks amp down here. So I believe for this one, they're actually feeding it up here through this preamplifier and sending that signal up the side there as well. You can see that one heading up that way. Now, with regards to the low power mode, looking at the circuit, and it's quite hard to see, but I think CaddX are basically sending this out from the input to this transmitter preamp here. There doesn't appear to be any amplification for the low power mode at all. It is such low power on this output. It's barely visible on the analyzer, as I've shown you already. And I believe they're just running this track up the side here. You can just see it there all the way up. And I basically believe they're basically tapping in either before the preamplifier or after it, but there's basically close to no main RF power coming out of these internal antennas at all. Now, as for what's under the can there, you can see the other one of the switches. So you've got the switcher here on the left. You can see coming out the little white component there and that track going up to that Skyworks amplifier, which I believe is a receiver PA. It's a Skyworks SKY1185614. And then the circuit is mirrored over here. So out of that one there, it comes out. You can see it then going sideways into that other Skyworks preamplifier there, which is heading up the side for the receive. Now, as for the antennas for the low power mode, you can see it there. It's running up the side, comes out there. You can see it there, and it goes into there. It is that little via that you can see going through there, and that is reappearing somewhere else. It could be reappearing on one of the IC pins over here. I'm not going to track it out, but the basics are they are feeding the low power mode antennas entirely separately from the main power amplifiers, and they're not getting any real RF power at all. Now, looking at the back of the board, there really isn't a lot to show you. It's just got multiple voltage regulators, a couple of protection diodes. You've got the V-regs there. So you've got an AMGS 560, AMGS 560, AMGS 560, some protection diodes. So you got 5 volt there from the look of it. They've labeled that pad. That's quite nice to see. Have they labeled any of the others? Ooh, power in, look there. 5 volt B there. So they have labelled some of the stuff on here, which is nice to see. We've got our LED over there, but really it's passive components. You've got your bind button. So if you broke that, it's located there. Not a great deal to see on this side of the board at all. Now, just taking a quick look at the other board. Now, there's not a great deal interesting here, but there is something I've spotted that has surprised me. So, we've got our main IC. I haven't cleaned it. It's the same as we have in all of them. I'll be honest, this side of the board is very much a copy and paste of the other boards. You've got your camera input MIPI there. You've got your dialog DA9602 regulator there. That's your main system management IC with 4 voltage regulators on board. So you've got a coil. You can see them there. Up here, we have the IE2000 transceiver. That was what I was expecting to find there. And then really, you've got a crystal and basic passive components. This side of the board is actually quite a copy and paste off their other boards. There's not that much different here. What has surprised me though, and I've just realized this, so if we look around on this side of the board, we've got our memory chip there, which is fine. We've got passives. We've got that horrible SD card slot. We've got some other sundry components. Not sure what that thing is. 2L3450E263D. I need to look into that. There's something, a space there for something called S5X5 or SX5. Not sure what that is. And then we've got our MIPI interface down here that goes through the boards. Now, something I've just realized looking at this is I'm actually shocked that there's no coax between these boards. That is our RF transceiver. So out of that will be coming the ready to be amplified RF 5.8 gig signal. That is what is coming out of that chip. And that then needs to be passed on to the amplifiers. So preamplifiers, then your main amplifiers. However, I would have expected, like in the HD0 VTX, there to be a coax connection here. But no, instead, they're sending it over the MIPI interface. I am a little bit surprised at that, if I'm honest. So over this MIPI cable, and it doesn't appear to be any real form of coax cable, it's just a standard MIPI interface, they will be sending 5 gigahertz RF. I don't know how much of an effect that is going to have on the behavior of the system, and I do wonder, could that be part of the cause for the interference, the noise that I was seeing on the VTX at low amplification? I don't know for sure. I'm not saying it is. But what I'm surprised at is we're passing 5 gigs RF over an interface like this, which isn't balanced. It's not coax. It's just a MIPI interface. Now, with regards to that internal cable, on my FPV wiki, I have the teardown images for the HD0 Freestyle VTX. I will also be uploading the new GT onto here under the CaddX section as well. Now, I just want to show you what HD0 have done here, because they have a similar setup in the dual boards where they are transferring RF between the two. And you can actually see here on the images that there is an internal coax cable that goes between the two. So you can see here, there's a UFL with the cable that comes off, and then on the bottom board there's a UFL input here for that coax input. HD0 have always done it this way when they actually transfer RF between the boards. If we have a look at the HD0 VTXs, the other ones, if we go down somewhere here will be the original one. Here it is. We've got the first VTX, which again also transferred RF between the PCBs. There is a huge connector here that you can see here that goes between the boards, and then that goes into here on this PCB here. So again, rather than using just like a MIPI interface cable, they're using proper coax to transfer this RF through. And whilst I can't say for sure this is the cause of that interference that you've seen earlier, it is definitely an unusual setup. Now, one other thing I did think about was if these internal antennas could be part of what we're seeing on the analyzer with this additional noise or these additional signals. It's worth remembering, as I said earlier, that these don't come out of the PAs. This signal actually runs up the side and comes into up here alongside this preamplifier. I do wonder if these antennas could be introducing some form of signal before the main PAs, because if it was able to get into here, that is going to be amplified then as part of the main power amplifier circuit. I'm not sure exactly why. It's weird because you see the signal come and then it will fade away at times, but there is certainly something different about the setup on this VTX that is causing that noise compared to what we've seen on all of the other ones. Just an observation on the PCB layout, there is a lot more going on this than we've seen on any of the earlier Avatar VTXs. It is a very complex design from an RF perspective. I'm not going to sit here and say, oh, they've made a stupid mistake or they've done something silly. This is a complex setup, and this issue that I've seen, they may not even be aware about, and it could be a very unintended consequence of the new design. RF design is black magic in itself, and you really can get all sorts of strange things happen. I would have expected this to have been picked up by the testing that it was done initially at the factory, but here and now, it appears to be doing it. It remains to be seen if it can be fixed in firmware. Okay, so to share with you my thoughts on the CaddX Avatar GT VTX. Now, as I've said already, this is not so much a review on the RF performance, but I am going to cover the things that we've seen here today. This is a really interesting product because it's great to see something that has more power output for the people who can legally use it than any other VTX that we've seen before. In my opinion, there is no question it is more than the 1200 milliwatts. I'm not going to say out and out it's 2000, but it's just a lot more power. It is a big VTX. I don't believe this is a VTX for 5-inch users. This is a VTX for people flying 7-inch, 10-inch planes, ground-based vehicles. I'm not saying you can't stuff it in a 5-inch if you have got the space, but it really is not a VTX, in my opinion, for everyday use. As you've seen, there are some quirks to this VTX, and there are some things I want to talk about around that. The RF behavior has some things that don't feel 100% right. It is pumping out at times an insane amount of noise, and I don't understand why it's doing it. As we've talked about in the video, it could be related to that internal cable not being coax. It could be related to the fact that you have the additional antennas that may be sort of recirculating or regurging the RF signal, but it isn't doing it all of the time. There is also some quirks around it leaving low power mode in my tests as well. It doesn't always leave low power mode straight away. When you arm, there can be a few seconds or more before it leaves. And in fact, there were a number of occasions where I could not get this VTX to actually exit low power mode. It just sat there in low power mode all of the time. The firmware does feel a little bit buggy on this, and I am going to feed this back to CaddX. With regards to one massive pet hate on this, I think the SD card slot is stupid. I don't understand for 1 second why it was not fitted with a standard SD card. I just think it's madness. It is no more of a friction fit than a standard latching card. It should just be a latching card like all of the others. Overall, though, if you're looking for a very high power VTX for the Avatar system, it is definitely worth a look. I like the fact that it is compatible with all of the cameras. You can use it with the Moonlight DVR only unit as well. As I did explain earlier, you can't record 4K directly on this. It will only record in 1080p max, but you can use the 4K option if you use the external DVR module too. And really, whilst there's nothing groundbreaking here, it is absolutely a VTX that offers something none of the others do, and that is a very high output power level. But this ain't a VTX you're going to want to use if you want to be flying at 700 milliwatts, in my opinion. This is full power, maxed out all of the time. But you are going to have to be careful with the cooling. It isn't able to keep itself under control all of the time. As I have showed already, the fan on the top cools the power amplifiers, but the main chipset, the main ASIC, that is on the bottom. You can see that when you look at the bottom, there's an area there. The power regulation is on the bottom. And as a result of that, the bottom of this VTX is going to need airflow. It might be okay in a quad, but on the bench, it will still overheat. The fan definitely helps keep it under control, but it isn't a permanent fix for it not overheating at all. And in any installation you're going to put it into, you're going to make sure that there is air moving around. I would actually try and suggest mounting this vertically, actually. I think that would be the best solution in a plane rather than horizontally, and having airflow then run over it either side. Now, with regards to the range this VTX is going to give you, that isn't something I'm going to talk about in this video, but I'm going to highlight one fact, and that is, it's worth remembering that whilst this VTX is going to pump out a load of power, your goggles are still limited to the same power they had before. It is a two-way system. As a result of that, your VTX needs to be able to hear your goggles, receive that signal. Your goggles are not outputting any more power than they were before. So as a result of that, you may not actually find a VTX like this actually gives you any more out-and-out range. What it might actually do, though, is give you a more stable link for the same amount of range because of the amount of power it is able to push back to the goggles. But it doesn't necessarily mean because it is now pumping out a lot more RF that you're going to get a lot more range, because you still have the limiting factor of the ground. You're going to want to make sure to get the very best performance from this VTX that you're using patch antennas, you're using very high gain directional antennas to the VTX. That way you're going to give it the best opportunity to hear that signal from the goggles. Overall, in the end, I think it's a very interesting product. It certainly seems to have some issues, but I'm not going to put it in a do not buy territory. What I would say is this VTX is not one for flying around other people. It is a VTX for long range, high power applications that you're not really going to be flying around others. And as a result of that, I'm more than comfortable to recommend it for those scenarios. But I don't recommend you use this VTX as your normal VTX on a standard 5-inch build every day, especially if you're flying around others. Now, if you're interested in getting one, there will be a link to this VTX in the description. I want to say a big thank you to CaddX for sending it over. Very interesting indeed. Finally, I just want to say, if you'd like to support the channel to allow us to keep making content in the future, please do consider checking out the link to my Patreon as well as buy me a coffee. It is only through the support of my patrons I'm able to keep making content on this channel. And if you'd like to support us to make content in the future, please do check it out. I want to say a massive thank you to all of my Patreons. We would not be able to do this without your support. Anyway, that's it. Look after yourselves, stay safe, let me know what you think in the comment section below, and I will speak to you soon.